Hello students, welcome to AriserTalent. I am your maths teacher Arpita Sharma. Students, we are discussing a chapter today that's theme is right, circle. So we were talking about what? Circles, and we have done the theory part, right? And we have discussed some theorems. So now it's time to apply that theorem on our questions and solve the questions, right students? So let's do it. Okay. So here's the question. In that series, I'm having from an external point P. External point P, remember from external point I can have at most two tangents drawn to a circle. Tangents PA and PB is giving me circle and a point outside the circle and two tangents from that particular point, that is PA and PB. Okay, are drawn to a circle with center O. Okay, the center of circle is what? O. If CD is the tangent, now CD is the tangent to the circle at a point E. Now where is this point E? Okay, and PA equals to 14 centimeter. Now length of PA is given which is 14 centimeter. Find the perimeter of triangle PCD. Now you have provided with this diagram. Okay, because here it's not saying the where is this point E. What can be done? It can be give you proper information that you're having a point E. It's not marking it here, so I'm marking it for you. So it can say you that a point on this circle is E and whose extension, which is a tangent, CD touches the point at the circle at E and cut the line AP at C and BP at D. If you are provided with this information, maybe this diagram would not be given to you in the question. Okay, but in this particular question, you have provided with less information, so this diagram is given. Okay, so be prepared for the questions in which you are not having the diagrams and you have to draw it yourself. Okay, students, so find the perimeter of triangle PCD. Now, find the triangle PCD here, PCD. So, we have to deal with this triangle. Okay, this triangle. We have to know the perimeter. In order to know the perimeter, what should I need to know is that I have to know the line CD's length and DP's length and CP's length. If I add CP, PD and CD, then I'll have the perimeter of this triangle. Now, the question arises, how will I do that? Because I have provided only with PA. So, PA is there. This is the point A. So, this PA is given, which is given 14 centimeter. This is the provided information only. Okay. So, how will you know this? So, what and what concepts are you going to use in this? So, first I will talk about then what and what concept I am going to have in that particular question, and then we will solve the question. Okay, it will make it you having this question a little bit easy. Okay, so okay. Now, I've told you if this is a circle here, if this is a circle, okay, and you're having its center as O and you're having an outside point here. This outside point here, name it P or name it T as you wish. Okay, so from this point, if I draw a tangent here and I'll draw a tangent here too, right? Now, what and what will happen? I've told you if this is T1 and this is T2, then PT1 will be equals to PT2. I've told you, so we are going to use this concept here. Okay, now I'll use this outside point at different location and you'll need to tell me that what and what will be the result according to this. Okay, so let's do this. Okay. Now, coming to the question, come here, this is our center O, this is the center O, and this is our circle. Okay. And these are tangents. This is a point A and this is the point B. Okay, students. Now, coming to the given part, what I am having in this, I am provided with a circle whose center is what, students? Is O, right? Having tangents, two tangents are there, PA and PB, PA and PB. Now students, what information is given? PA equals to what? 14 centimeters, right? So, what we need to find? We need to find perimeter of triangle CDP or PCD, you can say, right. Now the solution part comes. Okay, students. So in the solution part, what I'm using? I am using the C, this point C, as an outsider point, and from this point C, I am having two tangents named A and D. That is CA and C. Now, if I treat this point as outsider, point D, so from this point, I am having two tangents right there, that is DE and DB, isn't it? Right. So, I am having the same application over there, that this part will be equals to this part and this part will be equals to this part. So, you will be like, ma'am, why are you doing all these things? Because I am provided with this length only. Okay. So, somehow I need to use this length, okay, and find the perimeter of this triangle. So, I need to have some relation between these lines and then I will coordinate between them, right, students? Okay. So, solution. This PA equals to what? PB. Now, why? Because P is outside point and PA and PB are tangents, right? This is R, not and, it's R. So, this is one. Now, similarly, what I am having, AC equals to C, AC equals to C, and this ED equals to DB. Why? C and D are outside points and ACCE and EDBD are tangents, right, students? Okay, so mind this, that this point is outside point, so BE and DE will be equals and AC and C will be equal. Okay, now what I am doing? Now, PA equals to PB equals to what? 14 centimeter, which is given for PA only, but PA equals to PB, we know that, isn't it? Now, PA equals to PB. Now, what I can say, that implies PA plus PB equals to 14 plus 14 will be what? Equals to 28 centimeters. This is 14, this is 14, that will be give me 28 centimeter, right, students? Okay. Now, can I write PA? Can I write PA? This PA equals to PC plus AC. Okay. So, PA equals to PC plus AC. I bifurcate this PA into PC and CA. Now this PD, okay, this PD equals to what? PD plus DB, okay, PD plus DB. Now students, I can write this PC as it is, this PC as it is, then this PD as it is. So I have written this PD as it is plus this AC plus this AC plus this BD. Now students, if you look carefully, what is the value of AC? AC is C and the value of BD. The value of BD is ED. Okay, so I am just going to replace this and I am rubbing it till there. So note that part only. Okay. So I have rubbed the given part. Right. Okay. So I can write this implies that 28 centimeter equals to this 28 centimeter equals to PC plus what I have done PD here. Okay students, PD here. Okay, PC plus PD plus CA. CA is equals to what? C. Okay, so C and BD. BD equals to ED. So plus ED. I can write it, if I write it first, if I write it second and if I write it third. So from second and third equation, these values will be equal. Now implies that 28 centimeter equals to PC plus PD plus CE plus ED is what? Nothing but what? CD. So, okay, I'll write CD here. Now it's saying PC. Okay, I'm using a different chalk here so that you can see that PC, right? This PC, okay, plus PD, that is PD, okay, plus CD. So, this is CD and this is the same triangle whose perimeter we have to find. So, what? That will give me 28 centimeters equals to what? Perimeter of triangle PCD, right? And this is what we have to find. So, this is our final answer, students. Now, note this complete question so that we can move to the next question, right? Okay, note this. Okay. So, rubbing this. Okay, students. So, I am just rubbing this till meanwhile you can, have a look at the next question. That what is the next question? Okay, students. So, the question is find the distance between two parallel tangents to a circle whose radius is 4.5 centimeter. Okay. So, we have provided with radius only and we have to know the distance between two parallel tangents. Now, talking about the parallel tangent concept, students, what we have studied in a circle, we can have at most two parallel tangents only. Okay. We can have infinite set of parallel tangents, but we can have only two parallel tangents to each other at a time, right? So, what I am trying to say, if you are having this center and you somehow draw a circle on it, mind my circles for now. I am going to promise you that I will make right circles for you in construction, right? This is a promise for sure. Okay, so till then you can just have this circle. Okay, now I am having parallel tangent. If I am having a tangent parallel here, okay, now what will be the next tangent parallel to this? I'll draw a parallel line to this. Okay, so by construction I can do that. Okay, 90 degree here, and somehow I will be end up by this, like this. Okay, so what is my concept? If this is tangent and if this is tangent. So let's suppose this is xy and let's suppose this is PQ. Okay, these are two parallel tangents. This is parallel to this. So that's exactly this, right? 90 degree. Okay, no, now what I am having, that you're having, if you meet this particular point, the point of contact is what? When the circle and tangent touches each other. Okay, so when I'll draw a line to the center, it will give me what? Radius, or I can say that the radius is what? Perpendicular to tangent. In the other way around, it will be happen like this only. So this will be the radius and will be perpendicular to this tangent, and this will be the radius and perpendicular to this tangent, and these two will be what? Parallel to each other. So this is given, radius is what? 4.5 centimeter. If it's 4.5 centimeter, that will be also 4.5 centimeter. Now, do I need to say you anything? That what is the distance between them? This is 90. This is 90. So this will be the shortest distance between these xy and PQ tangents. So that will be what? Nothing but 9 centimeter, right? So solution. Solution is what? Draw a circle. I am writing this construction only for you. Okay. Draw a circle with center O. Second, draw tangent this is xy, right? Okay, at a point, name it A, O and B, right? At a point A, and draw tangent PQ parallel to xy. Now solution, now your solution part is here, which here says that xy is perpendicular to OA, tangent will be perpendicular to what? Radius, right? Similarly what? PQ is perpendicular to O and B, right? So, as in figure we are having what? The distance between PQ and XY tangents equals to OA plus OB, which is what? 4.5 centimeter plus 4.5 centimeter, and that will give you what? Equals to 9 centimeter. So this 9 centimeter is your nothing but answer. Okay, so you can now copy it. Copy it, students. We'll move forward to next question. Okay. So when I'm telling you this is tangent, mark it like this is not like this, but this is something like this, straight. Okay, consider this to parallel this. Okay, so I'm rubbing this now and we are moving to the next question. Okay, students, right? So where's the next question? Here. We have to prove, again the prove thing. So after two questions, we are going to prove something. Okay, so what we have to prove? two tangent segments BC and BD are drawn to a circle with center O. If you know, I'm supposing that we are not having this diagram here. So, how will you understand the question? Two tangent segments BC and AB are drawn to a circle with center O. So, this is a center and this is a circle and this is O. Now, it is saying BC and BD are drawn to tangents. So, BC and BD, that means common point is what? B. So, I am having a point here which is B. Now, if I will have tangents towards it, so the name will be BC and BD. Okay. So, this will be a construction. Are drawn to a circle with center O such that angle CBD. Now, angle CBD, this angle is equals to what? 120 degree. This angle is 120 degree. Prove that OB. Now, if you are having this OB, you have to prove about this OB. So, you will meet this. Okay. If you have to prove this, you are going to meet this. Right. Equals to 2BC is equals to 2BC. Now, this is something that the question is asking in a figure. So, this figure may or may not be given to you. Okay. So, it is fair enough for you guys to not have this diagram in your question. So, how you will make it? You will just follow the language and the diagram will be here. Now, this is what you are saying that ma'am, here's are two lines. Okay. And it is not upside, it is downward. Just rotate it. Just rotate this and this diagram will tend to this. And if you are even not rotating it, just draw. Your construction will be this. Now, you have to use this only. You don't need to make it exactly like this. Just follow the given instruction. You will be having the diagram yourself. Okay. So, this is our diagram. I am preferring this one. So, then you can have exact, you know, idea of a circle, the straight lines and the construction part. Right. Okay. So, I am darkening it. This is my circle O. This is circle with a center O. This is O point. Now, from this outside point B, I have drawn two tangent BC and BD. So, these two will be equal. Now, this length is given. I have to prove this length equals to twice of this. Now, this is my construction part. Right. So, can I do that all given things? Right. So, if I am talking the given parameters, I can write CBD equals to 120 degree. Right, students? What I have to prove? I have to prove that angle, no, it is not angle, it is about OB. Right. So, I have to prove that OB is equals to 2BC. Right. Then, what I am having other thing in bucket is I am having some construction over there. So, the construction part is what I have done else which is given, meet O to C and what? O to D. Right, students? This is my simple construction part. Now, I am here with this proof. I know what to prove, I know what is given, I know what to construct and I have done all these things. So, now the process start for the proof. So, this is the angle which is given 120 degree. Now, you students look here, this what concept I am using, that this is BC and this is BD. Now, this O is meeting the outside point from which we are having two tangents. So, what will happen to our theorems that we have discussed, that this line will be the bisector of this chord CD and the angle bisector of angle CBD. So, what do you mean by this? That CBO will be equals to OBD angle. Now, if these two angles are equal, what does that mean? If this angle is 120 degree, this will be 60 degree, this will be 60 degree. Clear? Okay. So, in figure, what I am observing, this BC equals to BD and angle CBO equals to angle OBD equals to angle half CBD. Right. Now, half CBD equals to 1 by 2 multiplied by 120 degree. Now, why it is so? Because BO is angle bisector of which? BO is angle bisector of angle C, B and D. Right? We have proved that theorem in our previous lecture, so we know this. Okay. That will be equals to 60 degree. Do I need to write? Right. Okay. Now, in a triangle, if I talk about this triangle CBO. Now, students, look carefully what criteria are you having? BO and BC. Now, BO is here and BC is here. So, you will be taking this particular triangle. I am showing with a different color. Okay. So, you have to prove this and this relation. So, you will take this triangle for sure. So, I am taking this triangle, right? In triangle CBO, what I am having, if I will take with this hypotenuse, this is 90 degree. Okay. So, this will be what? Base, and this will be what? Hypotenuse. Now, if I go with this, and I am reminding you the thing from trigonometry, right? We have told you that you have something like sine, cos and tan of theta, and how you will find them from a triangle? That was Pandit, Padri, Prasad, Har, Bole. Isn't the trick? So, you have known that this, if you are having this B by H, then you will go for cos theta. Now, again, I was having some table for you, then we were having 0, 30, 60, 45, 0, 30, 45, 60 and 90 degree. For sine, I was having what? 0, 1 by 2, 1 by root 2, root 3 by 2 and 1. This is, I am recalling you, we have discussed it earlier, right? We have learned this table, hai na? So, for cos, these value will be reversed. So, that will be 1 root 3 by 2, 1 by root 2, 1 by 2, 1. And if you are not able to recall it, just watch that lecture again and be clear about these values. The tan theta will be sin theta by cos theta. So, you can calculate the value of theta here, and I have also told you to just remember these values on your tips, that what is cos 60, what is sin 60, what is cos 30, what is tan 60, you have to remember it also. Okay. So, by this I can say in triangle CBO, cos theta. Now, cos theta, now theta is what? Theta is 60 degree, cos 60 degree. This cos 60 degree, this is 60 degree, will be equals to what? Base. This is base upon hypotenuse. Okay. So, cos theta will be equals to B by H. Now, cos theta equals to B by H. Now, cos is what? 60 degree. Now, 60 degree is equals to base, which is BC. So, BC by hypotenuse. Hypotenuse is what? OB. So, okay, OB, right. Now, value of cos 60 you can write from there, it is 1 by 2, you have to remember it, but I am taking it 1 by 2 from this table, implies that 1 by 2 equals to BC by OB. Okay, students. So, what I conclude from here, that this 2BC equals to OB. Right. So, my final answer is this, Hence proved, because this is what we have to prove, 2BC equals to OB. So, it is proven. Okay, students. Okay, so just note this completely, students, so that I can conclude today's chapter, today's session. So, in today's session, we have gone through with some concept we have read in our previous lectures. So, we have completed that, we have done some questions on it. In our next lecture, we will do some more questions, some more exercise on it, because you know exercise is healthy, right? So, let's meet in another lecture. Thank you so much.